Hi, Algebra B students. Ms. Shaw here, and today we're going to be talking about a worksheet that you guys worked on for your asynchronous assignment in order to prepare for our quiz on Friday. So this video is going to describe and go over some of the problems that you worked on for homework. Tomorrow in class, which will be Thursday, we'll continue on with this document and prepare for our quiz, which will be Friday. So after you guys watch this video, please reach out to myself, Mrs. Buchanan, or Mrs. Rosso if you do have any questions regarding some of these answers or some of the work that you may have put. Questions 1 through 4 are asking us to choose the correct name for each generic form of the quadratic function. So, for example, problem number 1, we see the form is y equals ax squared plus bx plus c. This is written in standard form. Example problem number 2 gives us the function y equals a times the quantity x minus p times x minus q. This is written in intercept form. Example problem number 3 matches what we see in example problem number 2. Therefore, example problem number 3 is in intercept form. And example number 4 matches example number 1, so therefore this is in standard form. Okay. Question number 5, intercept form is also called factored form. Because each parenthesis that we are given in this form is the factor, and we can use those factors to find the x-intercepts or the zeros. Question number 6 asks us to complete the chart below for each quadratic function. The first one has been done for us. So if we look at this first one, we see the function f of x equals negative 3x squared minus x plus 5. The reason it is concave down is because of this negative out in front. Does the graph have a maximum or a minimum? Well, all concave down parabolas have that maximum value. That is the very highest point, peak, hilltop, mountaintop that you can have in a parabola. Function number 2 is the function of 1/2 x squared minus 5x plus 2. Because this function is positive, okay, has nothing to do with the a value being 1/2, it has everything to do with the 1/2 being positive, this is going to be a concave up parabola. So it looks like this, okay? And again, you do not have to draw these if you don't want to, but a concave up parabola has a minimum value because this is the very lowest point or the dip that you have in a positive parabola. Okay. Function number 3, negative 0.1 times the quantity x minus 3 times the quantity x plus 1 is going to be concave down because of the negative out in front. And we know that concave down parabolas have maximum values. Okay. And then last but not least, we see the function 82 times x times the quantity x minus 21. Now, even though this x value does not look like a traditional factor in the sense that there's no integer being added or subtracted to it, we know that this actually still gives us a 0. X times x is x squared. We know it's still quadratic because the 82 is positive. This is concave up. And we know that all concave up parabolas have a minimum value. Question number 7 looks a little bit like question number 5 in the sense that you may see more than one vocabulary term that means the same thing. Another name for our zeros are our x-intercepts. Okay. So in order for us to answer number 8, notice number 8 has parts A and B. Okay? It's asking us to determine the zeros for the following quadratic functions and show necessary work. Well, in order for us to solve, we do need to set each function equal to 0. Right now, they're only set equal to y. So we can go ahead and say 0 is equal to 3 times the quantity x minus 2 times the quantity x plus 5. Okay, In keeping with the ZPP, the zero product property, okay, anything that is being multiplied together that equals 0 has the ability to be 0 in itself. So we can go ahead and set each piece equal to 0. Now, right off the bat, we should see an error because of this right here. 3 can never be equal to 0 because 3 is its own integer. It does not have a variable attached to it in order to solve for. So therefore, this actually cannot work. Now, if you didn't show this step, that's totally fine as well. Some of you may have seen it right away right here. But if you did show the step, 3 cannot be equal to 0. So now we're going to go ahead and we're going to tackle this x minus 2 equals 0. We're going to add 2 to both sides. When we do that, we get that x is equal to 2. Okay? And then for this part right here, x plus 5 equals 0, we're going to go ahead and subtract 5 from both sides, and we get that x is equal to negative 5. Now, we're not done yet because it did ask us for the zeros, so we do want to write our final answer as ordered pairs. So we can go ahead and say 2, 0, and negative 5, 0. And voila, there we have it. And you can even box those two answers if you'd like as well. Okay. And then last but not least, we can go ahead and look at b. Okay. B is the function of f of x is equal to 82 times x times the quantity x minus 21. Now, just like we saw in example problem A, we do have this 82 out in front. When we set everything equal to 0, right away we should know that this 82 can never be equal to 0 because there's no variable attached with it to solve for. So if you'd like, we do not have to show that step that 82 cannot be equal to 0. So we can go ahead right away and say that x is equal to 0 right here. And we can go ahead and say that x minus 21 is equal to 0. For this step, your work is already done for. There's nothing else to solve because x is isolated. So x is just 0. For this side right here, we can go ahead and add 21 to both sides. We get that x is equal to 21. Okay. Therefore, we know our two ordered pairs are 0, 0, and 21, 0. And there you have it. Okay, I'm going to go ahead and zoom out a little bit and just adjust the settings on this page. Okay, but next up, we are going to look at problem number 9. It asks us, what is the axis of symmetry for the parabolas with the zeros 5, 0, and negative 1, 0? Now, because this is not in standard form, okay, not in standard form, and we're already given the zeros, we're going to use the average. Okay, so we're going to go ahead and use the average to find this. We're going to take each x value, 5 and negative 1. We're going to add them together. 5 plus negative 1, okay, gives us positive 4, right? 5 plus negative 1 is really the same thing as 5 minus 1. So that gives us positive 4. Positive 4 divided by 2 gives us positive 2. So therefore, the axis of symmetry is where x is equal to 2. Okay. Making a picture may help as well, because if you think about it, if you have this coordinate plane out off to the side, and you have an x value of 5, 0, 1, 2, 3, 4, 5, and negative 1, 0 right there, there are 1, 2, 3, 4, I'm sorry, I skipped one. I forgot 0. 1, 2, 3, 4, 5, 6. 6 spots. So if you go 3 in and 3 in, 1, 2, 3, you do get that middle term being the line where x is equal to 2. So that is the axis of symmetry. It cuts it in half. Now, for example, problem number 10, it asks, what is the axis of symmetry for the function where it's given to us in factored form? So there's a couple ways that you can go about doing this. The first way that you could go about doing this is that you could find the zeros first and then take the average of them. You could also double distribute the function and then use the opposite of b over 2a. Personally, when it's in intercept form, the easiest and most straightforward way for us to get this is to take the zeros and then to find the average of them. So if x minus 2 is equal to 0 and x plus 8 is equal to 0, we know that our x-intercepts are going to be positive 2 and negative 8. And if you need to show your work to see how we get those, you would add 2 to both sides, you would subtract 8 to both sides. So then we can take positive 2 and negative 8, and we can add them together. When we do that, we get the value of negative 6. And in order for us to take the average of those two numbers, we would divide that in half. So divide by 2. When we do that, we get the value of negative 3. So therefore, x is equal to negative 3. That is the equation of the line for the axis of symmetry. And remember, your axis of symmetry should always be set equal to x because it is a vertical line. Okay? So those are our answers for example problems 1 through 10. Let's go ahead and let's take a look at 11 on the second page. 11 is going to be an example for us that takes us through the entire page practicing sketching a parabola based on the given function that we know. So number 11 gives us the function of x squared plus 3x minus 4. Now notice, I do not have a calculator anywhere in my hands. So we definitely can do all of this work without needing our calculator. Now, you will have it out with you probably when you're doing this asynchronous work, so you can always use it to check. And you'll probably have it out during your quiz, but just know that everything we're doing right now, we do not need a calculator for. So 11a asks us for the equation of the axis of symmetry and to show the necessary work. Well, because this is given to us in standard form, we are going to use the opposite of b over 2a. When we do that, the opposite of b is negative 3 over 2 times a, which is 1, okay, which is negative 3 over 2, or negative 1.5. So it's really up to you how you'd like to write it. X is equal to negative 3 halves, or x is equal to negative 1.5. Okay. Now, how do we know what the coordinates of the vertex are? Well, we would go ahead and use this x value of negative 1.5. And we can go ahead and substitute that x value in to find y. So we would say y is equal to 1.5 squared plus 3 times 1.5. Sorry, and keep in mind it's negative, minus 4. So let me go get my calculator. This is a perfect example of where we can use our calculator for this. So we can go ahead and plug in, okay, negative 1.5 squared, and I can zoom in for you guys. Plus 3 times negative 1.5 minus 4, and we get negative 6.25. Okay, so that is our vertex. Now, for part C, it asks us for the coordinates of the y-intercept. Okay, well, there's a couple ways we can do this. We always know that the y-intercept is our C value in standard form. Okay, or what we can do is we know that our y-intercept always has an x value of 0. Zoom out. So it's our job to find y. So we can also go ahead and substitute 0 for x. 0 squared plus 3 times 0 minus 4. When we do that, we get that y is equal to negative 4, just like how our c value is negative 4 as well. And we can go ahead and write that out if we want to. Okay. Part D asks us for the coordinates of the x-intercepts. Show supporting algebra to justify your answer. Well, if we have the function f of x is equal to x squared plus 3x minus 4, we could use a plethora of methods. We could use factoring. We could use the quadratic formula. It does not look like we could solve by square roots because we do have a b term. So the best method, probably the best practice, is to try and factor it. And if that doesn't work out, then you can use the quadratic formula. Okay? So our job is to find two numbers that multiply to negative 4 and add to positive 3. So multiply, add. Okay? Well, a couple things that come up to mind are 2 and 2, maybe 2 and negative 2. Well, when you add those together, you get 0. So that doesn't work. What about 4 and negative 1? Okay? When you multiply that together, you get negative 4. When you add that together, you get positive 3. So works. So therefore, we can go ahead and set this equal to 0, and we can factor this as x plus 3 times x plus 4 times x minus 1. Okay, and then if you want to check your work, you can double distribute. You end up getting that this is 4x, negative 1x, 4x, negative 1x, give you positive 3x, right? So therefore, we can go ahead and set x plus 4 equal to 0. We can go ahead and set x minus 1 equal to 0. And we can subtract 4 from both sides. You get x equals negative 4. We can add 1 to both sides. We get that x equals positive 1. And we're actually going to take these two values and we're going to use them for our intercepts. So we know that our x-intercepts are negative 4, 0, and 1, 0. Part E now is asking us to sketch a graph that includes the key characteristics from above. So we're pretty much going to take everything we did in A, B, C, and D and plot that, and then we can just fill in the parabola once we know all of those. So we know that our axis of symmetry is negative 1.5. So we're going to go over here where we see this x value of negative 1. Okay. That is our axis of symmetry. So between negative 1 and negative 2 is negative 1.5. So we're going to go ahead and just sketch in that vertical line that's dashed. Okay, and then maybe somewhere near it you can say x equals negative 1.5. So they know that that's an equation of the line, just like that. That's part A. We're all done. Okay. Part B asks us for the coordinates of the vertex. Well, it's a little bit hard to graph something like this and plot this point, so we're just going to try our best here. We know that the vertex is going to lay where x is negative 1.5, so on that dashed line. And we know that the y value is going to be negative 6.25. So we're going to go ahead to where x is negative 1.5. We're going to go down negative 2, negative 4, negative 6. Negative 6.5 would be somewhere about right there. And we get it. It's like not the most perfect point for us to be dealing with, but we still know how to plot it and it's still there. So we have to make sure we have it down. We know our y-intercept is at 0, negative 4. And that's this point right here. Okay. And then last but not least, we know our x-intercepts are negative 4, 0, and 1, 0. So we can plot that 1, 0, negative 4, 0. Okay. And really, once we have all of those key pieces of information, we can go ahead, make sure that our parabola is rounded at the bottom, not like a V. Make sure it crosses through the y-intercept, both x-intercepts, Make sure it has arrows at the end, and that is our parabola. Now, part E and F and G go along with the sketch that we just made, right? And kind of the questions that we were answering before. Like we talked about in class, the domain of the parabola is all real numbers. Okay, it is designated by this fancy curly looking R that has two vertical lines. So if you wanted to write this instead of all real numbers, that's totally fine. And we talked about the range being this inequality. The range is the y values, right? Domain refers to our x values, range refers to our y values. And when we have this concave up parabola, we're actually going to read our range from the very lowest point to the very highest point. So we're going to read from down up. Well, if we look right here, our very lowest y value was that y value of negative 6.25. Okay? We know y is the values that we're looking at, and we know that any y value can be bigger than negative 6.25. Like if you use this point right here, negative 4 is bigger than negative 6.25. If you took the y value of 0 right here, 0 is bigger than negative 6.25. So your y value is going to be bigger, greater than, or equal to negative 6.25. So that's how we would start the inequality. Negative 6.25 is less than or equal to y, because negative 6.25 is the very smallest value you can have. And then we see as the parabola moves up and outwards, right? The domain is all real numbers, so it's constantly going to get wider as it goes up and up and up and up and up. But as it's getting wider for the domain, it's going up and up and up and up and up forever. And because we have those arrows, we really don't know if it's stopping, and it's really not stopping. So therefore, our y value goes all the way to infinity. And infinite numbers, there's so many possibilities that are way up there. So, and then last but not least, we have G. Circle the appropriate descriptors, okay? As you can see, it is concave up, right? We graphed it. There was no negative value in the function. Therefore, it's positive. And then also, there is no vertical stretch or compression because our A value is just this 1, right? If there's no number there, x, it's not just 0x squared, it is 1x squared. So therefore, that this is neither. So if you've gone ahead and went through the process of watching this video and checking your work and making any corrections you have, please go ahead and put a big star right here and go ahead and maybe put a smiley face next to it as well, just so that way myself, Mrs. Rosso, Mrs. Buchanan know that you did watch the video, you did check your work, and you were following along with today's asynchronous assignment. We will make sure to scan this key into Classroom so that way you have it. But we hope you guys have a great rest of your day. We hope if you were a junior taking the SAT yesterday that it went well. And for all those students that you enjoyed your day off. We will see you on Thursday when we begin reviewing for the quiz again. And then Friday will be our quiz. And then before we know it, we'll be talking about a whole new type of quadratic function vertex form starting next week on Monday. So have a great night. We will see you guys later. Bye-bye.